Section 9.8 is a section that tries to get you to understand and link the different kinds of models that we have studied so far. Linear models, y equals mx plus b. Exponential models, y equals a to the x. Or a quadratic model, which would be that ax squared plus bx plus c equals y. So that's what we're going to look at today, is how can you look at the equations and determine which model it is. The linear model, again, is the y equals mx plus b, and that's always going to be the graph of a straight line. The quadratic model, or the exponential model, is going to be the a equals p times 1 plus r to the t if it's growth, or 1 minus r to the t if it's decay. And then the quadratic model is the ax squared plus bx plus c equals y. Now, it's pretty easy to tell when you look at the graph. It's not quite as easy when you just look at the equations. If you're just given the equations, then what you're going to do is you're going to make a table of values by using some plug and chug, and then you're going to plot some of the points on a graph to take a look at it, and then you're going to make your determination. Is it a linear, exponential, or parabola? Easiest way to do this, of course, is with a calculator, because it'll draw a nice graph really quickly for you. All right, so we have three equations right here, and we start to ask you, how can you determine what kind of model this is? And the easiest thing to do is to put the equations in a standard form or in function form by getting the y by itself on one side. In the first equation, you can see that it's a second degree polynomial, and so it has a linear term. And I would hope at this point that maybe some of you could even look at this without plotting points and say, hey, this is an ax squared plus bx plus c model, which means it's going to be a parabola. And I would hope that as you look at number 2, you'd say, hey, that looks like a y equals mx plus b, so that must be a linear model. And in the last one, I would hope that you'd say, hey, look, the variable is in the exponent. That's an exponential model. Now, is this exponential model going to be growth or decay? Well, that depends on what's inside of the parentheses. And since, of course, this parentheses is a number that's bigger than 1, this must be exponential growth. So I would say that you could either take your calculator out, plug these in, and take a look at what that graph is, or you can make a t-chart and you can plot some points, or you can look at the equations themselves and ask yourself, what does that look like to me? What model does it fit?